All right, so here we have this polynomial. It's a third degree polynomial. F of x equals 2x cubed minus x squared minus 20x plus 10. Right, so what we're going to do is we want to use the rational zero theorem to list all the potential rational zeros. Okay, so what we do is we set p equal to the last number here, which is 10, right? So then the p are all possible factors of 10, right? So what are all the numbers that multiply together to equal 10? Right, so it's 1 times 10 and 2 times 5, right? So 1, 2, and 5. So all the possible values of p are 1, 2, 5, and 10. And then q would be all possible factors of the first number, the leading term, right? The leading term is x cubed. So then q would be all possible factors of 2, right? What are all possible factors of 2? Well, it's got to be 1 and 2. So then what the rational zero theorem tells us is we have to get all combinations of p divided by q, right? So all possible combinations, including the positives and negatives of p over q. So let's just list them out, right? So we get 1 over 1, right? We get 2 over 1, we get 5 over 1, and we get 10 over 1. Okay? But then remember, it's p over q, so now we have to take each of these numbers, divide them by 2, right? So we also get 1/2. You notice 2 over 2 is just 1, which we already have here, so we don't want to write it twice, right? Then we have 5 over 2, and then we have 10 over 2, but 10 over 2 is just 5. We already have that down here, right? So if I ask you how many possible rational zeros are there, right? Remember, these are possible. It's not guaranteed, right? But out of these, the possible rational zeros here we have, well, let's just count them up, right? Remember, we have to also count the pluses and minuses too, okay? So 1, 2, 3, 4, 5, 6, including the negatives, so that makes 12 possible, okay? So the thing is, we know that one of these is guaranteed, at least one of these is guaranteed to be a zero. Okay, so then how do we know, right? How do we know which one is a zero? Okay. So we can use synthetic division or we can evaluate it, right? Remember, if we plug in a number, right? If we plug in a number and we get 0 as the answer, then that means that it's a solution, right? So I know at this point there's no other way around it. We just have to plug in numbers and hopefully we get 0, right? So we'll just keep doing this until we get the first one. So let's try plug in 1, right? F of 1. So we get 2 times 1 cubed minus 1 squared minus 20 times 1 plus 10. Now let's work all of this out here, right? Well, this is just 2 minus 1, right? So we get 2 minus 1 minus 20 plus 10. So 1, negative 19 plus 10, which is negative 9. So what does that mean? It means f of 1 is equals negative 9, which means that 1 is not a 0. Okay. So then we just got to keep trying to plug in numbers, right? Let's try 1/2. So we'll plug into 1/2 and then see what happens, right? So we get 2 times 1/2 cubed minus 1/2 squared minus 20 times 1/2 plus 10. Now 1/2 cubed is 1/2 times 1/2 times 1/2, which is 1/8, but 1/8 times 2 gives us 1/4 here. Right? So we get 1/4. 1/2 squared is also 1/4. 20 times 1/2 is 10, plus 10. Oh, check it out. Look what happens here. Everything cancels out. We end up with 0. So what does that tell us, though? It tells us that 0, or the remainder is 0, which means that 1/2 is a solution, right? So now that we found the solution, what should we do? Right, now that we found a solution, we should go straight into synthetic division, right? Let's break down this polynomial. So we'll do the synthetic division. Now, once again, we know that we should get 0 as a remainder here, right? We know that. So let's bring down the first number. 2 times 1/2 is 1. We'll add this together. 0, we get 0 here. We get 20. I'm sorry, that's a negative 20 here, right? I'm sorry, negative 20. And if we get negative 20 here, and then negative 20 times 1/2 is negative 10. And notice what happens when we add these together. We get 0, right? We expected that. But remember, what's the whole point of doing this synthetic division here? What do these three numbers represent? These represent the coefficients of a polynomial that is 1 degree less. So if you started out with an x cubed polynomial, then this should be the coefficient of x squared, right? So 2x squared plus 0x minus 20. And then we want to solve this guy here. Okay? Well, how will we solve a quadratic equation of this type? Okay? Now we could use quadratic formula, right? But you notice that it's missing the x term. So in this case, right, we'll just go ahead, we'll add the 20 over to the other side. We'll divide both sides by 2 to get x squared equals 10, right? And from here, let's just use the square root property, right? Let's take the square root of both sides. So x is going to equal plus or minus the square root of 10. Okay? So what are the three solutions here? The three solutions are 1/2, positive radical 10, and negative radical 10. Right? Remember, this is the rational root that we found, right? Radical 10 is not a rational number. It's an irrational number. Okay? So out of those 12 possible rational roots that we found, right, one of them had to work, right? And so we found the 1/2, which did work. And then we found the other two solutions, okay, just using some algebra here. So these are the three solutions.